I'd like to welcome you all here today and thank you all very much for joining in on our July School of Agriculture and Environment seminar series. It's my absolute pleasure today to welcome Dr. Lisa Micheli from the Pepperwood Foundation as our guest speaker for July. And so Dr. Micheli has joined the Sonoma County's Pepperwood Foundation in October of 2009 as its inaugural executive director, and she now serves as the organisation's president and CEO, which is excellent. So she brings more than 30 years of experience applying her technical, policy and fundraising expertise to the design and implementation of ecological restoration, research and educational programs for the foundation. And so she started her career at the US Environmental Protection Agency and then completed her graduate studies at UC Berkeley as a NASA Earth Systems Research Fellow in 2000. And so this year, as a 2022 Global Fulbright Fellow, she's visiting us here in Australia, conducting comparative research on some approaches for improving our understanding of relationships between climate, watershed health, wildfire and biodiversity. And so it'll be great to hear about some of that today. And so with no further ado, I'll hand over to you, Lisa, and let us begin the seminar.
Thank you, Caitlin, for that warm welcome, and thank you everyone for joining us today. Yeah, just before I dive in, my background is really in watershed science, but also very much applied science. So I'm a physical scientist who works largely with ecologists and then also government agencies and other kinds of researchers. I'm really passionate about interdisciplinary research, and that's how I met Dr. Sally Thompson, who's my host here today. And so I'm excited to talk to you about the work that we're doing at a California, I guess you would call it a conservation estate. We call it a research station or a nature reserve. And the work that we're doing to try to support landscape level strategies, particularly around climate and fire resilience. So I'm going to go back to this. And is everyone seeing my screen?
Yes.
Yes. Great. So the talk today is about climate smart conservation in Mediterranean type landscapes. And this is a shot of Pepperwood looking out towards the Pacific Ocean. And I have to say, having had a chance now to spend a month going out on field trips in Western Australia, you know, it's like the landscape looks incredibly familiar, but the players are different, right? So a lot of the morphology of the vegetation and the landscape is very similar, particularly the expression of the vegetation, but then it's so neat to go up and go, wow, this is a plant I've never seen before. This is not a California oak, this is something else. So it's a pretty exciting thing to have a chance to look at a fresh landscape and think about some of the questions that we've been pursuing that I'll talk about today. So it's actually, I put 2022 Fulbright in quotes. I was actually a 2020 Fulbright, and that obviously got delayed as much of our lives did due to COVID. But the idea was take an opportunity, and this is what they call a global Fulbright. It's actually more of a professionally oriented Fulbright as opposed to the academic ones you might be more familiar about that are more like academic post for a year or two assignment. This is a 6-month travel window for up to 3 countries. And I did have a chance to go to Spain and Catalonia to start asking some of the questions here. That was the part of the trip that was cut short. And I have partners in Chile where we're doing similar work, and then obviously the work here in Western Australia, and talking to people in South Africa, probably participating in the Medicoast workshop remotely from there. But as you know, from living in one of these climates, we've got wet winters, very dry summers, second in the world really in biodiversity, only to rainforests, and yet our Mediterranean landscapes are often working landscapes with only 4% of them protected. That's an important role that Pepperwood plays, and that a lot of the lands have already been converted to agriculture. So we're often working in a mosaic of working in natural landscapes. And one of my peers, Rebecca Shaw, has done some modeling showing that with climate change, the climate is changing in these areas, and only about 50% of these areas worldwide are expected to retain their current climates. So what does that mean for us as conservation professionals working in both working and protected landscapes? Is a big question we have, and how can we help these landscapes retain their resilience in a highly water limited environment? So Pepperwood is, we frame ourselves as a leader in science-based resilience solutions. You could call us an environmental organization, but we're not actually an advocacy group. So we don't do any policy or political action or project support or legislative support. Although I will have to say, in recent years, with the climate emergencies we've been facing, we are increasingly a source of data and scientific information for policymakers. So it's an important role that we play. And since we're an NGO, we can often be kind of flexible and more nimble than a government agency, and also play an interface with our university partners who, of course, have certain restrictions or commitments they have to maintain. So we're kind of like the glue that thinks about how to stick these parts together and fill gaps that the university and agency realm can't fill. Our location, this is the state of California over here. We're up in the Northern California coast ranges. These are north-south trending low mountain belts that were formed by the Pacific Plate subducting under the Californian plate. And if you've ever been to San Francisco, that's the yellow dot here. Our reserve is about an hour and a half due north of San Francisco. Over here in Contra Costa County is where UC Berkeley is. That's where I went to school and where I met Sally. And so we're really well positioned to tap into the university community in the area. We have 3,200 acres, which I should have switched to hectares in my mind, but it's about 1,500 hectares. And over here on the right-hand side, you're looking at our Dwight Center for Conservation Science. This is actually a month after the entire property burned in 2017. I'm going to be talking more about that. But this gives you a sense of our context and the mixture of grasslands and conifers and oak woodlands. And behind us is the Mount St. Helena, which is a very important mountain to our Indigenous partners, and one of the 4 or 5 defining peaks of the Bay Area. So our preserve is a site that we use for testing land stewardship and water stewardship methods, instrumenting the site to measure everything that's happening in the environment in real time, long-term studies, monitoring change on the ground over time that we can relate to remote sensing partners' work, and then straight up sort of biological survey and research, a lot of which we host visiting scholars who come and utilize the preserve for that purpose. We are based in the homeland of the Wapo people, the 𝑬𝒏𝒗𝒊𝒄𝒖𝒍𝒕 tribe. They're not a federally recognized tribe, so we have a special relationship with them to treat them as such, despite their lack of government recognition. And I will just encourage you, the Wapo and Pomo people make absolutely beautiful basketry, which is not just a practical practice, but it's a spiritual practice. And they're deeply tied into the plants and animals of the region. So we can talk more about their role with us. So I thought I'd just give you a little bird's eye view since we can't do a field trip today. But here is, again, looking towards Mount St. Helena. And this is relatively recently after one of the recent fires. The hills behind that are a little bit bald would have been covered with chaparral pre-fire. But again, you can see this sort of combination of vegetation cover, relatively rugged terrain. And one of the things I will say is very different about our sites from here in Western Australia is that we have relatively thin soils over these bedrocks. So the hydrology is actually quite a bit different than here where you have those deeply weathered ancient soils. Just again, this is one of our grassland transects that we do long-term monitoring to give you a sense of the rolling landscape. Supply, I would say, transport limited geomorphology in these hills, making these rounded slopes. Amazing spring wildflower displays that are enhanced really by fire. And we're never exactly sure what's going to come up until it happens, but generally we need a pretty good rainfall in the spring to get a show. Lots of people come and use the preserve, although it is not open to the public. It's not open for recreation and park but we have people come for classes and visits and special experiences. These are part of our stewards who are bringing out grasses to do restoration work. And we are basically a headwaters system. We have these ephemeral streams that run intermittently, but we are a very important catchment for water and water supply in the area. And those who know stuff about California know that the Sierras provide a lot of the water supply, the snowpack in the Sierras for California, but we are actually not in that region. All of our water is captured in local watersheds and then fed into the aquifers and streams that we draw from. So this is a map of the preserve. The high points are in red, and this is just giving you the sense of how much instrumentation we have deployed on the property. So when I was brought on board to take over this land and set up a program, I basically said to my boss, look, I want to instrument this site to be a climate change experiment and to measure everything that if I were an ecologist in the year 2100, I would wish people had measured during this period of very rapid change in our landscape. So there are 54 long-term forest monitoring plots. There is a soil moisture and weather array of 25 plus stations that complement those plots, 26 long-term grassland plots, 13 chaparral plots, 5 to 25 forest recovery plots, monitoring birds, herps, etc. So we're accumulating a big pile of data, and I would say one of our challenges is actually processing all of that data, but we're hoping to be sort of a living laboratory or an encyclopedia of the life and landscapes in this region. Also very important, for over a decade, we have had a Native Advisory Council working with us and bringing their knowledge to bear on the property. I would say we're relative pioneers in this arena of bringing Native people back to conservation lands and partnership. And so I like to say that we're a place where Indigenous science is meeting Western science to forge the solutions that we're working on. So our work is divided into 4 key initiatives. Given my talk, I'm going to focus more on the climate and fire resilience, but just giving you the overview. And this was an exciting dimension, evolution for us in 2020. Prior, we sort of do research and we do education and we do conservation action. And historically, we organized our strategic planning that way. But this time we said, let's really take a look at the impact we want to have on either our community or the environment. How do we combine those 3 superpowers to shift the needle on the conservation status and the beliefs and actions of our community? So the first is so fun. We have an incredible education program. We serve elementary school kids. We have a summer teen program that's happening right now. These are some of our teen natters. We have partnerships with the local junior college and the local state university, both of which are Hispanic serving organizations. And we really believe in the research that says that these early experiences in nature can really shape a conservation ethic for a lifetime. So we love getting the kids out on the trail. It's 100% science standard focused in terms of their learning outcomes. They have a great time, and we've had to bring in with the fire work that we've been doing sort of trauma informed and social and emotional learning. Our kids, probably half of them lost their schools in the last 5 years to wildfires, and probably a third of them at least lost their homes to wildfires. So we have to be really sensitive when we're teaching fire ecology to put it in a context of deep understanding of the trauma our community has gone through. We also partner with the University of California on California Naturalist and now a new climate steward certification. So this is an adult learner. Often people are looking into new careers or just wanting to become more effective volunteers in their community. Here they are learning about our new flux tower. I'm going to talk more about in a little bit. And then this, I would say the silver lining of COVID for us is we just, after my educators resisting online products, really had to go online with our materials. We also made a commitment to making those Spanish language friendly. So we do have a YouTube channel, and if this kind of stuff turns you on, there are great, almost all of our webinars are now recorded, and There are offerings called Wild Wonders for kids. So those of you who still get to homeschool or on school break, it's great, like 4 to 5 minute explorations of the natural world that the kids can then do at home. So a lot of our restoration work on site in terms of ecological restoration is focused on our grassland systems. We feel like they are probably in some ways the more degraded of our systems because there was a historic traditional cattle grazing operation on site. So we do feel like we've probably lost carbon from the system, that there's been a certain amount of erosion. There's a lot of invasion of European annual grasses. And we feel like we can make a big change through a number of management measures. And we're measuring that change. So here is actually a cross section of our soils. This is about as deep as they go. We're lucky to get a meter or two that our tech made for the California Naturalist program. And they're pretty clay rich when you get into there. So this really is the water savings account for the landscape, the soil moisture that gets held on here through the year. And the right-hand side is just an example of a quadrat that we would be using to do our monitoring. We are measuring sort of native and non-native cover and composition every year, also thatch and thatch buildup. So we have quite at least a decade's worth of data right now that relates to our management. So our management measures include prescribed fire. We really were one of the first conservation estates. One of the things that's impressed me in here in Australia is how extensive your prescribed fire program is. I've also heard that there are ways it could probably be fine-tuned for ecological objectives, but we were one of the first properties to start working with CAL FIRE to demonstrate that burning could be used. In this case, it's very well suited for one of our invasive weeds. We're still not doing super large areas, but we're seeing the impact. And then we have a conservation grazing operation on site. So again, perhaps an unlikely partner, but working with a local cattle producer and timing this just right. We have been quite influenced, as I think many have, by sort of Savory Institute thinking about short duration, high impact grazing, moving the animals through. These animals are to some extent simulating elk herds that would have been present in this landscape until the 19th century when they were extirpated by early American settlers. So this has been actually a very successful program for us in terms of helping to meet ecological objectives. And then we do every year gather native seeds from the site, propagate them in a shade house and greenhouse structure with our volunteers. This is one of their favorite activities. And where we have intensive disturbance due to construction or road work, or in the case of recent fires, we had 25 miles of bulldozer lines that the state agency installed to fight the fire on the property. This is where we go in with a more intensive planting approach. And we're also planting actually some of our burn pile scars after burning materials as part of our forest management. And here they are out getting them into the field. So another big focus for us is linking landscapes for wildlife. I'll have to say this one got bumped a little bit by climate and fire the last couple of years, but we are coming back strong to it. We have 50 long-term wildlife cameras on site, and they are distributed in a spatially explicit grid. So it allows us to do pretty quantitative analyses of the occupancy statistics for this site. And one of the funnest creatures we get to play with are bears. Well, we don't play with them, but we get to observe them on the camera. We had 9 bears on the property last year, 2 moms with 4 babies. This is a bobcat. And here's one of the cub pairs and babies. I think that cub is playing with mom's tail. They're highly entertaining. But besides having these great tools to let our community know who's in the neighborhood, it is also, as I said, a way that we can get quantitative metrics of change over time. And things were really surprising. Like one surprising thing was we hadn't actually seen a big cat. These are Puma concolor on the left. Nobody had really seen one on the property for 9 years. Once we got the cameras out, it turned out that 30% of the time there is a cat on our property, and we're often a breeding site for for kittens. And having this knowledge base is giving us a chance right now. We're diving into the statistics, particularly looking at the 2 years before and after recent fires. How does the landscape respond? How do the animals respond? And what we're finding is sort of a cascading effect in terms of the little guys coming back right after the fire to take advantage of the big flush in growth that we get. And then you see the predators coming in, a sort of staged effect. So the good news is our wildlife seem to be surviving these conflagrations, and we still have more to do to understand how to support their habitat and also how to avoid in our area, because we do have a lot of farms and working on this, how do we avoid conflicts with humans and livestock? So we have done a lot of work on climate smart connectivity. I almost could have given the whole talk on this, but that might be another talk, but I will encourage you. It's in the journal Land. Morgan Gray, who's our lead conservation analyst, published 2 papers, one which was her PhD thesis, where the question was, how could you evaluate or design habitat corridors or wildlife corridors to achieve climate adaptation benefits? And what we found is we could take high resolution climate change projections, intersect them with the permeability layers for the landscape, and then actually quantify, what's the cooling benefit of this linkage? How much cooler could a plant or an animal get if they travel this pathway? The journal also asked us to publish a almost more of a social science paper on the collaboration itself. This was a 2-year collaboration across 3 of our counties with all of the different county land trusts and park agencies involved, and really tried to honor and tap into their local knowledge as well as tribal knowledge to verify what the computer thought it was seeing and to fine tune the management priorities. People are now using these products to help raise money for acquiring new protected areas. Here, the protected areas are in green. This is Pepperwood down here. Or to influence their stewardship priorities for those. And we're really excited. We've had 2 vineyards who are right adjacent to us ask us to help them develop habitat management plans for their properties. And where you see this Knights Valley area, this is another preserve to the north, the Modini-Mayacamas, where we also have 25 wildlife cameras, and we're really excited to drill in on acquisition and stewardship recommendations for this area nearby us. We have this is a visiting scholar project from Sonoma State University in Point Blue with ourselves, using audio moths, which are basically recycled cell phones, to record birdsong and to relate bird distributions captured that way to remote sensing of habitat. And can we start to estimate where birds are using remote sensing? This is just one of a lot of fun and interesting projects that visiting scholars bring to us and then utilize the preserve for. And they have a lot of bird data to tap into. We have a partner organization, Point Blue Conservation Science. They are world leaders in bird research. And we use their breeding bird survey methods to track birds over time. And I think it's one of the best examples we have right now of a biological indicator that we can pair with climate and drought conditions. This is bird species richness that's showing you sort of a dip in species richness over the most intense periods of one of our most recent droughts. And then we can look at the impacts of the fires here. And here you sort of have a mixed message, right? A little bit of an increase after 2017 Tubbs fire, a little bit of a decrease after Kincaid. And what's really important is to be able to break this out by species. This beautiful warbling vireo, which is a songbird in our area, likes riparian habitats, wetter conditions, and we're seeing sort of a steady decline in their use of the preserve over time, which I think is largely a drought signal. And then meanwhile, our western meadowlark, who is a ground nester and seems to almost benefit from whatever is the competition happening here, that they are doing better than drought. There's also a lapis lazuli who also seems to be a fire winner. So understanding that when we have these disturbances driven by fire and climate, there are winners and losers most likely in the animal world and in the plant world. So how do we keep track of that and balance that in our conservation goals? So diving more deeply into the climate and fire resilience work, I'm going to start with the climate work, which is the work when I first connected with Sally. And a lot of what, well, I will say that there is a collaborative that Sally and I belong to called the Terrestrial Biodiversity Climate Change Collaborative. And part of what we have done is take the very best empirical data collection and then the extrapolation to models and maps and mapping our region based on that understanding. So the right-hand side is showing you just the domain of one project we did, which was for Marin County, Sonoma County, the Napa River Valley. And if those of you who like California wines might be recognizing some of these names. And then the Mendocino County portion, the blue blob is actually the Russian River Basin, plus two smaller basins. That basin is managed by our local water agency and provides water for 600,000 people. And so they were very interested to get some projections of hydrology, as well as looking at fire hazards. It turns out that our water agency is quite concerned about fire because the ash can compromise their water treatment system. So this is one of our first applications working with local agencies. This graph is showing you the universe of climate scenarios that were available in 2016 when we were doing this project. 0, 0 is no change from baseline. And as you move right, these are degrees centigrade, increases in average temperature. So you can see there is a range of scenarios that go up to about +7. And the y-axis is showing you the change in precipitation. So this is one of the most challenging things for working in our area, is that it is an equally valid hypothesis that over the long term, we will get up to about 30% more rainfall than we have historically, or alternatively about 25% less rainfall. So this is actually a graph that we use to choose models with managers. And that's one of the things I would say is most important if you're working in an applied setting and trying to get your work used. Even at the outset, you need the managers in the room about what are your assumptions that you're going to use in a modeling exercise like this. And for them, they said, look, we really want the end members. These optimistic or mitigated scenarios are not really what we're concerned about. And then we had this sort of warm and moderate rainfall, which was the midterm element. Once we had these scenarios, we utilized a basin characterization model to assist with the downscaling and to take basically the temperature and precipitation projections from those models and feed them into our local watersheds with the best resolution data we had possible in terms of soil conditions, topography, aspect, and geological permeability of the bedrock. And this was really important to me because when I first got into this work, it's like, okay, all the projections are temperature and rainfall, and yet if you're doing a river restoration project or an ecological restoration project, you actually want to know about soil moisture, you want to know about stream flow, how do we get to that? So this started a long partnership with two modelers, Alan and Lorraine Flint, who are now emeritus from the U.S. Geological Survey, to work on this model and calibrate it for local areas. It's available for all of California in 270 meters. We have it for the preserve at 10 meters. So it can become a pretty precise tool, and particularly looking at micro refugia in the landscape, which more coarse models were not able to capture. And one of the things that came out of this exercise was a term called climatic water deficit, which can only be calculated if you have actual soil moisture storage estimated so that you can measure the difference between the potential or maximum evapotranspiration that could happen versus the actual evapotranspiration that is limited by what the soil can hold. And this kind of resolved this uncertainty around, are we going to be in a wetter or a drier climate? Because even when we took those very high rainfall scenarios and ran it through the model, there was an increase in deficit over time. So I think of deficit as basically drought stress. I find it very handy because it brings the temperature and the precipitation together. And it turned out that for the vegetation modelers, this was like a secret weapon to get their models to be very accurate. And maybe it's not a surprise, but where plants can grow are a function of how much water they have available. But it also seems to correlate with irrigation demand, which can be hard to measure directly. It definitely pointed to where we had tree die-off during the droughts. And it also is a surrogate for live fuel moisture, and that's an active area of research for us right now, is taking direct live fuel moisture conditions, because that means it is another, it actually is one of the top 2 indicators of potential fire hazard in our area. We were able to develop visualizations that showed change in potential seasonality. The top is sort of now on a monthly basis, and everything in blue and green is liquid water that you could access in some way, whether it's in the soil or runoff or recharge. And that red blob is the water deficit that happens during the summer months. So we could start to simulate earlier onset of summer conditions and the increased water deficits that for our area is about 6 to 10 centimeters of equivalent rainfall per year, which is about 10% of our incoming rainfall, is projected to be evaporated back out and a deficit moving forward. It also helped us think about drought in sort of 2 different ways that drought impacts us. Obviously, we think about drought in terms of water supply and drying out the reservoirs, but that is really a different kind of drought than thinking about the landscape drought that stresses trees and increases fire hazards. And this is showing that the thinking about water deficit is something that it can accumulate over time, and then thinking about, okay, well, if you get back to some kind of normal rainfall, how long will it take for the landscape to recover? And in terms of water supply, you know, maybe it's about half a year of decent rainfall, but we were finding where places were very dried out in terms of the soils, that you would be looking for more like 2 or 3 years, perhaps, of normal rainfall needed to really bring back soil conditions that are representative of a more average year. I just had to throw in here as a bridge that, you know, we also started modeling essentially the effects of increasing climate on fire. Again, this is that weird blob of Marin, Sonoma, Mendocino, and Napa all together. But we released these projections in 2016. And then in 2017, people thought we were really smart because almost everything you see in very dark red over here caught on fire the next year. So as much as we were looking at this as, hey, by the end of century, we might be seeing these conditions, I guess my take-home message for you all is that things that we were projecting to happen in the last 30 years of the century have really been happening to us almost every year in the last 5 years. So now we're really moving out of long-term projections to how do we get real-time hazard data into the hands of our emergency responders, et cetera. This is just giving you a sense of our fire neighborhood. So again, our funny little origami fish over here, Pepperwood. These are the fires that have happened since 2017. We had a pretty quiet year last year. The 2020 fires are being shown in this multicolor spectrum that some of you may be familiar with. These are fire severity indices that are derived from satellites. And one of the first things we did after the most recent round of fires was conduct that analysis and get all of that data out to land managers in those zones. And then we also provided them basically standardized ecological monitoring protocols that they could use on the ground, so that we will have a regional data set that looks at what is the ecological effect relative to the satellite estimate, right? The satellite estimate is all about reflectivity and a change in greenness. There are certain things like grasslands will always come out as a super high severe burn, although they may be quite resilient. So we're trying to validate on the ground what the satellites are seeing and understand the variability of conditions. And as you can see, we've been dealing with kind of consecutive droughts. I got this from the U.S. Geological Survey, and it's interesting, like this drought ended in 2010 and this one started in 2011. You're seeing that we're really only getting a year of maybe normal rainfall in between these high drought years. This is just zooming in on our own geography. This yellow is the 2017 burn. It's called the Tubbs Fire. It's drawn a lot of attention because in 1965, almost exactly the same footprint burned, except it did not cross this freeway. It also, and our historical ecologist has found that it also burned in 1923 and 1870. So the reason why this place is consistently reoccupied is the topography turns into a funnel that captures the winds and funnels them right through. And the puzzle we have to sort out here is, you know, in 1965, that fire that occupied the same footprint took about 6 days to travel from where it started over here in the east and then to move down into the city of Santa Rosa. The fire we experienced in 2017 took 6 hours. In 1965, no lives were lost, 100 structures were lost. In 2017, 44 lives were lost and 8,000 structures were lost. And our CAL FIRE folks, and this was really one of the first big mega fires, said they had never seen anything move like it. And it was the perfect storm of drought-stressed plants and overstocked forests. I'll talk more about that, but we have a lot more fuel in our forests. We estimate about 10-fold the number of trees per unit area compared to Indigenous stewardship times. And then the fact that we have development creates the ignition sources, which were in this case power lines. We have since had lightning fires, which were supposed to be very rare in our area, so that is also thrown us for a spin. We thought we could concentrate on wires and turning wires off and burying wires, but there are other sources that we're going to have to worry about for ignitions. The red polygon is the 2019 Kincaid fire. It started to the north and moved towards us. And I like to say it's sort of a tale of two fires, because in 2017, as much as we were teaching everyone that we were in a fire-dependent ecosystem and it was, you know, sooner or later going to happen, our whole community, including us, were not super prepared. And in 2019, some of the preparedness measures that I'll talk about, including wildfire cameras, which we have set up on our property, really helped provide the emergency responders better intel. There was so much more coordination and communication on the ground. And they basically stopped this 2019 fire at Pepperwood. We had a number of CAL FIRE trucks and all the crews living on our property to hold the line there. And they basically used our grasslands that were grazed and helped slow down the fire as a place to stop the fire from reoccupying Santa Rosa. But we also have this odd distinguishing feature of having most of the overlap between that 2017 and 2019 burn on our property. So I will say mainly the fires kind of, as you see, cookie cutter here and pause when they reach each other, but we had enough dead standing fuel left from the first fire that it actually burnt pretty hot into our property. So one of the questions we get to ask as researchers is, you know, how much fire is too much fire? We know that we need some fire in our ecosystem and it's adapted. But in this case, we're seeing, in this case, we're seeing some conversion to weeds from multiple fires. We're also looking at these intensely burned areas. They are definitely coming back, but we're basically measuring everything about them, how the plants respond, how the fuels respond, how the water runs off, how the wildlife respond, etc. I will say there's amazing fire followers that come out after these fires that are rare plants that aren't seen but for fires. This is our redwood lily. Our preserve manager who lost his home said that was kind of sad, but he was really hoping to see one of these flowers. So we were glad they popped up. But this is really, as I said, leveraged our monitoring to be not just about long-term understanding, but hosting the fire cameras, hosting a flood warning system. These fire cameras are available 24/7 now for people. This is what it looks like when you go on. We can steer them any way we want. This is our property when there's not a fire, but as soon as the fire kicks in, the first responders take over, and all these little pointers are different cameras that they can steer to triangulate on a location to characterize it right away and get fire behavior information that before they had no access to. What we have found is that all the climate and watershed modeling we did has been really helpful for refining wildfire hazard maps. So we have a model hazard map for our local county that's now being consecutively picked up by neighboring counties. On the left, I'm just showing this is what the state map looks like for hazard. And you can see that if you had a farm in that whole red zone, you wouldn't necessarily know where to start. And so the finer scale data gives people a little bit easier chance of prioritizing places where they might want to do fire reduction hazard. And when we talk about forest thinning, I know it's starting to be kind of a debate in environmental communities, but what we're really talking about in our case is removing these Douglas firs that you see invading on the right-hand side. They don't like fire, and because fires have been prevented from burning, they have been invading these landscapes. And when the fire comes, they're a perfect ladder fuel, a ladder fuel being the kind of vegetation that carries the fire up into the canopy, which is actually the main cause of any kind of mortality that we see. And the left-hand side, you can see this is where we've taken out the Douglas fir. And again, we're doing this in concert with our Indigenous leaders. We used to leave the stuff that we cut lying on the ground. That was the recommended Forest Service practice. Those areas burnt very hot because they hadn't had time to decompose. So we now do this whole other step of pile burning. And this is an example of how we're using our data to address, shift our management right away. And we had 2,000 of these piles to burn this year. But we're also, doing this in a culturally appropriate way with our Indigenous leaders. And basically, our hope is to reset this landscape so that we will not suffer these large catastrophic burns, and we can start to do smaller scale mosaic burning moving forward. A lot of people in our community who are doing this work are native Spanish speakers. So we now also have land stewardship materials in Spanish for people. And then we also do a lot of work with our other partners serving private forest landowners. And these forests in our area, Sonoma County has 17,000 different parcels of forest. They're not publicly owned, so we have to get to private landowners. And we're also going to be working on Indigenous food sovereignty, identifying plants on the preserve that were traditional foods beyond black oaks, which we've worked quite a bit on, and stewarding those with our native partners. So just drilling into water, and I'm going to go a little faster so that we have some time for questions, but this is just showing you the kind of indicators for water we're collecting. The black spikes are rainstorms over time. And this is both a forest and a grassland data set. So this is showing you the soil moisture accumulating and then drying out by the end of the season. So we have this repetitive, wet up, dry down cycle. And we're one of the few places that has this kind of comprehensive soil moisture data, which is used directly by our utilities and is also now a big draw for people doing remote sensing of soil moisture. Again, just our streams tend to dry out. This is not super common, but this is what we're looking at as well as how can the soil moisture balance affect the water balance in the streams. And we're super excited to have just gotten the resources to put in a eddy covariance flux tower to get at the water and also the CO2 coming out of the system. And we're doing it as a paired watershed study that will take a look at, I should move that thing out of the way. We'll take a look at comparing two streams, one where we've done some significant thinning, one where we haven't. I'm not sure how much of a signal we'll pick up about that, but the long-term benefit of then measuring these over time, both of these basins did burn. So we're sort of actually getting a double burn and stewardship effect. That's what it looks like from the sky and giving you a sense of the different monitoring going in place. And then ultimately trying to refine these evapotranspiration as a function of land cover for a whole bunch of different applications, including water and fire modeling. And then super exciting, this is an example of a drone partnership we have with the U.S. Geological Survey National Innovation Center. This is one of the younger researchers at USGS. She's getting her PhD, and she will be calibrating these drone soil moisture surveys that were first developed for agricultural lands, and now we're testing in our landscape. And similarly, we have researchers doing ground-based LiDAR, drone LiDAR, hyperspectral, airborne LiDAR, airborne hyperspectral, and satellite. And we're a great site We want to do a change analysis over 10 years using all those tools to see how they relate to each other with metrics for regional application. And then just a little teaser, while I was coming here, I was talking to my partners, Alan and Lori Flint, and they have actually just completed a first pilot of testing out their basin characterization model for Australia. So on the left-hand side, you're seeing a map of growing degree days that came out of that model for California, and they zoomed in on grape growing regions, table grapes, to compare to grape growing regions in Australia to look at potential future changes. They utilized what they could use freely available. I'm sure there's a lot more they could do to calibrate this massive model, but as far as I know, this is the first pass of something that might get water deficits at this kind of scale for you all, and showing off some of the analyses that you can look at peak runoff. And these are actually changes in the last decade compared to a 1960, 1979 baseline. So things that are yellow and red, there's been either decreases in runoff or water availability, whereas in blue, there are potential increases happening. And again, here's your water deficit, a baseline compared to 2011, and the ability to look at these sort of deltas in water deficits where aridity might be on the increase or the decrease based on recent shifts in climate. So just summarizing, our goal is to help fill data gaps, to convene scientists, especially across disciplines and across cultures, to support local land and water managers, and then doing demonstration projects on our land that can then in turn inform landscape level solutions. I will say a fun thing that we've been involved with for the last year was just that California has adopted a 30 by 30 goal for the state. If you're not familiar with 30 by 30, the idea is to conserve 30% of nature by 2030. How we do that and how we measure our success is a deep conversation that we're involved in, but it's a great example, I think, of how our bioregional work at the scale of the multi-counties I've just been showing you can feed into a statewide strategy and provide really crucial local expertise on local ecosystems. So that's it. I would love to open it up for any questions.
Wonderful talk. Thank you so much, Lisa. That was fantastic. And I'm sure I speak for everyone. I say thank you for a really great talk. So yes, anyone has questions, do feel free to either pop them in the chat, or you're more than welcome to unmute yourself now and ask them directly to Lisa. While you're all having a bit of a ponder and a think about that, I will use my host privilege and ask the first question. It was really lovely to see a flux tower feature in your talk because I'm an eddy covariance person by training. But I was curious about whether or not, with a lot of, because you clearly demonstrated that you're measuring quite a lot of things at the Pepperwood Reserve, have you been looking at changes in carbon stocks, even just from a tree survey sort of point of view, that could be used to sort of scale up and compare with the eddy covariance once it gets up and running?
Yes, so above ground, yes. Below ground, we're still looking for help because it's so hard, but that is where the LiDAR is super helpful. So we have both traditional plot surveys of demographics, but then we also have a researcher, Lisa Bentley, who is using ground-based LiDAR to get that structure and the carbon estimates really strong. And the airborne LiDAR is actually really good for that too. But of course, that gives you these snapshots, right? So that's part of our change analysis she's doing very comprehensive since the fire. Well, and the nice thing is we had the 54 plots before the fire. So she's capturing sort of the rate of carbon accumulation above ground, which is happening very rapidly post-fire. And then hopefully getting an airborne survey in 2023 to compare to 2013 will also give us a chance to look at forest structure and biomass. But there's a lot of uncertainties around that, especially like what's dead, what's live, which matters a lot. And like I said, the underground carbon, we're really, especially in our grasslands, we're really curious on whether we can shift the needle on that, and we don't have really any strong methods for that yet.
Yep, fair enough. Everyone's hard. Sorry, was that someone who's got a question?
Hey, Lisa.
Hey.
Hey, it's Dan. Hey, that was really inspiring and a lot. It's really neat to see how you're doing so much, connecting it to management so explicitly on such a large scale. I love it. I'd love to see more of it. This is what I've been trying to inspire here. I'm really looking for, I mean, I have 1,000 questions. They're all like super detailed and probably not appropriate for me to run through here, but I'm really looking forward to chatting with you this evening. It's going to be great. Thanks so much. It was really good.
Yeah. Well, I think it's a great example of, as I mentioned, to be honest, like we have a lot of data that we need partners to help analyze. So that's one of the things when you start getting the volumes of data that the new sensors let you get,
Right.
you need to prioritize how to analyze them. But it has been a real gift of the fires, actually, that we were able to get more automated systems in place. So at least the climatic data is being fed into a system that's tracking it. And then it's really, I would say primarily it is the treatment efficacy monitoring, which is people are the thirstiest for and is very time consuming. So lots and lots and lots of plots and stats to do.
When you're predicting for, I don't remember which thing you presented you were talking about, but when you're predicting for climate scenarios, is there any connection to what sort of climate goals, what the predictions for those might be? I'm just trying to connect it.
For targeted climate, like
climate
for the targets, I would say that's a lot of where we started is like, let's compare business as usual to mitigated scenarios and hope that that's compelling to people. One challenge of that argument is that mid-century, they're not super different. So people don't see the big difference between. The mitigated scenarios really just get you halfway to the business as usual scenario. So it is doable. I mean, to us, it was relatively compelling. It was like, wow, this looks really bad, the mitigated scenario. And then this looks really, really bad, the non-mitigated scenario. So that is, something that can be done and has been done. But I think there's been so much urgency to like, well, if this is where we're headed and this is what we're dealing with right now, and this is the challenge, right, with the projections work and the vulnerability work. As soon as you get that to a manager, like, okay, so what does it mean? What are we going to do? Like, that's a whole another deeper conversation we have to have about what are the levers or knobs that you can turn to be more resilient. And sometimes I think when we talk about adapting ecosystems, it's like, well, the ecosystems are going to adapt, like, and how much we can help them adapt is to be a little humble about that. But, for me, it's like increasing soil moisture holding capacity seems like an obvious one. And that's where getting the more below ground carbon in place is important. And that's for us in the grasslands, we feel like getting to a native grasslands, that's really where the carbon sequestration happens because of the huge depth and mass of roots that you get down there, even if you don't necessarily get the non-volatile or non-label. And then just it's a big debate about the fire, mitigation. This is the thinning and the vegetation management piece. And if I could figure out how to get more water in places that have less water, I mean, we're, you can do that at sort of micro scale. And we haven't gotten to the point where our poor little turtles that we're bringing in a water truck and putting water in the pond, but we're on the verge of going there, but the question is where, making more water is hard.
Lisa, I just wanted to interrupt, sorry, just because there's lots of good questions in the chat and I don't know if they're not coming through. Great. Yep.
Yes, I was going to, thank you. I was going to bring, I guess, segue into that because some of the topics you've been talking on are, I guess, related to that. Sally's asked a question about whether there's economic insights into what's needed to achieve resilient landscape management and understand that side of things. And I guess that also forwards on into Kim Brooksbank's question about ecological thinning and that it's expensive. And so how do we get that important work funded, and is there an opportunity to use the material for, say, bioenergy production or maybe even biochar to add back to the soil? So if you don't mind commenting on a bit further on that, that would be lovely.
Yeah, well, I think the economic insights of conservation in our area, especially like right where we are, like you could grow very valuable Cabernet Sauvignon on these hills, right? And so that's where the fact that, you know, our founders, the Dwights, helped fund setting this land aside is huge. Acquisition costs are very, very high. But there's also right now, because of 30 by 30, more resources for that. And that's where our land trusts are really just important partners for, you know, they think about, if I have $50 million, you know, what are my top 10 priorities for capturing lands? And definitely they have had more success in the philanthropic world getting that money if they can show there's a climate benefit. So that's where sort of the corridors helped, and it's helped make them compete with limited resources. But I also think this is why stewardship is such an important effort, and it's hard to shift stewardship in a community. But when we're a local organization that people love and love to come visit, and we can host workshops and we can train landowners, et cetera, that's the more economic solution, right? Not to have to buy it outright. On the ecological thinning, like, yes, it is expensive. It's at least $1,000 an acre for us to do that work. And I was involved with a whole sort of causality mapping around resilience project with mainly biologists, soil scientists, and foresters. And even we agreed that the limit is not knowing what to do or even the state of the science as much as the not having the funds there. Funds for things that we know have economic value. And this is where the private land ownership problem is challenging, right? Because the person who bears the cost of the treatment doesn't necessarily realize all that value because it may be downstream of them. I have been involved with what resources are out there having financial incentive and technical assistance programs for private landowners, because that's the carrot, right? Like, well, you get 50% of your costs covered and the cost of the forester. I think the real economy of scale here that we've been very involved with is, instead of each of those 17,000 people going for a plan where they need a forester and this, and it's pretty expensive just to get your plan and your permits, like, can we help? We're trying to help our neighbors get a 50-kilometer squared plan for 200 property owners who all buy into it. And then we only have 2 foresters anyway in Sonoma County. You can stamp this, and they're like, oh yeah, I'd much rather stamp a plan for 200 people, you know, and then deploy more cost-effective methods. So I think there's some economies of scale there, but big social challenges to get people aligned. But interestingly for me, I did a lot of that similar kind of work on rivers, where you try to get everyone living on the river to team up on a project, and so we're making some headway. Yeah. And using the material for bioenergy, you know, these are not this. You saw those little things that were taken out. They don't really have market value currently. There are portable biochar units that people experiment with on a really big property that's hard to do, and that's why we're doing that pile burning. We do try to make them sort of low intensity so that we are getting that carbon back into the soil, but we can't guarantee it's all biochar at that point. But that is people are interested in biochar. It's just like, how do you make that operational? We're not quite sure. And again, there's a certain amount of pushback in the environmental community against biomass. I mean, kind of the fear out there is this is bringing big timber back, and they're going to take all the big trees and convince them, like, actually, we're talking about the small trees, and we actually need a little big timber back because we don't have any mills, we don't have any processing plants. Since the 60s, there really hasn't been a timber industry in our area. So I think it's partnering. I see Xavier's.
Yeah, so Xavier's question, I think, is also building on your what you've just been talking about. But in particular, I think his point number 2 here, what is your take on valuation of biodiversity, and was that conducted at Pepperwood? And then I guess you sort of touched on briefly how the local community were impacted by the project. If you have anything further to add there, that would be lovely as well.
I have to say, when I was a student, I was really allergic to this valuation of biodiversity, because it's like, do we really have to put a dollar sign on it? But yes, apparently we really do have to put a dollar sign on it. So that's one of the things I'm interested in learning about on my Fulbright here, actually, because I think there are some groups really doing great work on that. So, so no, we haven't done that, but we could be a partner. There was an assessment done for Sonoma County that we're involved with that used these kind of, you know, U.S. nationwide values, and sometimes I just really wonder about those. But to the point of, can we do such an in-depth project anywhere in the world? Yeah, I think we can. And I think part of what I hope is to spread this idea of a model, like we are sort of a field station on steroids, but I do think that if we had 12 or 15 of us who were doing work in a consistent fashion in California, that would take us a long way towards being able to tell the natural resource managers what's going on. And so that's part of the dialogue I'm in with 30 by 30. How could you create a network of these kinds of sites at a scale that's relevant? And that will be my pie in the sky goal for the rest of my career. And in terms of the community impact, I have to say, like, you know, people really value having a Pepperwood in their community. And we are largely actually supported by private and personal donations. And yes, we do live in an area where quite a few like multimillionaires have retired, so they're able to do that. But people, first of all, really value going to the property and seeing nature up close and personal. And couldn't believe it after the fires and even after COVID, like people could not wait to get back and continue their on-site learning. I think that the local agencies see us as a boon and not a thorn in their side, because we often are bringing them things or bringing in research dollars or doing stuff really on the cheap for them that they'd have to pay a real engine, you know, a real consulting firm a lot more for. So I would say that the community really is more welcoming. A lot of people still don't even know there, but I think it's reassuring to people, and they feel like it's a real value add to have what is turning into, thanks to input from people like Sally, like a world-class research institute in their backyard that's, you know, focused on answering questions they care about that impinge on their well-being and their livelihoods. I'm seeing Kim mentioning that we have some of the similar issues around thinnings, around cost and social license here. So, yeah.
Cool. Thanks very much. That was a really detailed.
Lisa, what would be intake for our Western Australia? Because we don't have large scale like your California fire, but we have fire and we are suffering. And what would be your advice? Just few words so that I can.
You have to work together.
Yeah. Large scale.
It just comes down to working together, like, and local people have to be really connected resilience wise. Like that ended up being the most important thing, is like, do you know your neighbors? Does everyone know each other? Do you have a list of everyone? I mean, these are more rural areas. Sometimes people don't talk that often. Do we know who has mobility problems? Do we know how to open the gates if the power goes off? I mean, if you really think about, if you had no vehicle and no power, who would you be able to communicate with, and what would your strategy be? And that's what really shocked people, I think, in our first fire, is that the power went out, gates didn't open, garage doors didn't open. So people were completely unprepared for that. So I think thinking about what happens if you don't have your technology, and who are you going to talk to, who are you going to call? And in the end, it's like our local, because the local agencies are so overwhelmed, they're like, yeah, you guys, we need block captains, we need, you know, people for your neighborhood will volunteer to be on a list. So we have one person we can call to see how you're doing, because the firemen can't be, you know, many of my friends said, I knew a fire might happen, but I just thought there would be firemen there or firewomen, and there weren't enough.